Let's talk about virtual destructors and why they are important with a simple example. Here there are two classes, class A and class B. Class A is the parent class and class B is the child class. Class A has an integer pointer as its private member variable, while class B has a double pointer. Let's quickly fill out the constructor for class A and class B. So since in class A we are allocating an integer pointer, we use the new operator and allocate the space for an int on the heap. Likewise, in class B we allocate a double on the heap. Now for the destructor, all we need to do is to clean up the memory that we allocated in the constructor. So we use the delete keyword and we delete both A pointer and B pointer in the respective destructors. Now in main, let's declare a pointer to class B and let's assign it to an object that we allocate on the heap. And at the end of main we delete that pointer as well. Now when I run this program, as I'm allocating the object on the heap, the constructor for B will get called, and as you can see, the constructor of B calls the constructor of A, and after the call to constructor A is done, we execute the code in the body of constructor B. So we should see the call to constructor A followed by the call to constructor B when I run this program. And we see what we expect in terms of the constructor calls. So for the destructor, we call the destructor of class B. We delete the pointer that we allocated in the constructor for class B, the B pointer, and after the destructor call to B is done, the destructor of A is invoked and we deallocate the memory that we allocated for the A pointer. Now let's try to change the pointer to a pointer of class A, and this is perfectly legal because B is a child class object and a pointer to a child class object can be assigned to the pointer of a parent class object. And let's also delete the A obj pointer. So when I run this, one of the things that sticks out is that we only call the destructor to A, and the destructor to B, this call is getting skipped. Now this is problematic because in the constructor of B we've allocated memory that points to a double, and the deletion happens only in the destructor to B. The fact that the call to destructor B is getting skipped is indicative of a memory leak. And the reason the destructor call to B is skipped is because the pointer that we have declared in the main is a pointer to class A. So when we hit this delete, the destructor corresponding to class A gets invoked. So in order to avoid this, we add the virtual keyword to the parent class destructor. Adding the virtual keyword to the parent class destructor makes it a virtual destructor, and the compiler, when it hits the delete statement here, it is smart enough now to recognize that the pointer that it is trying to delete, even though it is declared to be a pointer of class A, it is holding an object of class B, and because of the virtual keyword it will call the appropriate destructor. So when we run this program again, now that we have the virtual keyword and we have a virtual destructor in the parent class, we should see the destructor for B getting invoked, followed by the destructor called to A. So we should see the B destructor followed by the A destructor. So when we run this, you can see that adding the virtual keyword made sure that we called the proper destructors, and it avoided the memory leak problem that we were originally running into. I hope this helps understand the importance of virtual destructors. I'll see you guys in the next video.